Hi, and thank you for clicking on this video. I'm Rustam, and the title of the talk is No Finite Model Property for Logics of Quantified Announcements. This is the joint work with my colleagues and co-authors Hans van Diepenich and Tim French. As you've already noticed, the main result of the paper is actually in the title of the talk, also in the title of the paper. So we're going to follow the classic storytelling device featured prominently in popular films of the 90s and early 2000s that we're shown the final scene, we're shown the outcome, and the real question is, how did we get here? So in our title, we have two interesting things. First, logics of quantified announcements, and then finite model property. So the questions we'll try to answer during the talk are the following. What are these logics of quantified announcements, and what is the finite model property? And finally, why the lack of it is interesting. In order to introduce the logic of quantified announcements, first we need to introduce public announcements. So we're going to do it by an example. Consider the situation where three children, Alice, Bobby, and Claire, are arguing about the existence of Santa Claus. Alice knows that Santa exists, which is represented by proposition variable P, while Bobby and Claire consider it possible that Santa doesn't exist, represented by the negation of P. Also, children don't know about each other's beliefs. So the whole situation can be represented by this epistemic model, where the current state of the evaluation is S, or this squared state, and indeed in the current state Santa does exist. There is a line connecting two states labeled by an agent if agent considers these two epistemic alternatives equally possible, or in other words, they cannot tell one state from another. For example, in model M, which is our model in state S, it is true that P, meaning it's true that Santa does exist. Also, it is true that Alice knows that P, meaning that in all A reachable states from the current one, P holds. And this is not the case for B because there is a B reachable state here to the right where P does not hold. So also note that in the model, all the relations are equivalencies, so we omit transitive arrows and reflexive arrows. This is not. It is not always. It is not also the case that C knows that Santa exists because she considers it possible that he doesn't exist, and then the diamond is merely a dual of the box, meaning that B considers it possible, or there is at least one B reachable state where not P holds. So now assume that in our system, in our kind of static scenario, we're introduced with a new piece of information, and this information is revealed to the system publicly and simultaneously to all the agents, and this is what is called public announcements. And agents' knowledge may change as a result of public announcements. For example, after public announcement that Alice knows that Santa exists, we get the following model, and how do we arrive here? We just find all the states where the current formula which is being announced is not satisfied. We delete these states and delete all the corresponding relations, and then consider the updated model. Also, we can consider a bit more convoluted formula, and then you can pause the video and check that indeed the resulting model looks like this. So the basic logic with just knowledge is called epistemic logic. This is your classic S5 model logic. The logic of knowledge with public announcements is called public announcement logic, which extends epistemic logic with the following constructs. Public announcements update the model, meaning that we preserve in the model only states that satisfy the formula which is being announced and all the corresponding relations, and delete all everything else. So from semantical wise, the box modality, the knowledge modality is the classic model box, meaning that for all states reachable in one step by the A label transition, in all those states phi holds. And for example, the box for public announcements says that if phi is true in the current state S, then in the updated model, once we deleted all the states that do not satisfy phi, psi will be true. Also notice that as a result of the update, phi may become false itself. So an interesting thing about public announcement logic is that actually having this ability to talk about these modal transformations, which are public announcements, doesn't allow us to distinguish more models or describe more properties of underlying models, because for each formula of public announcement logic, there is an equivalent formula of epistemic logic, which can be found by using an appropriate translation function. And thus, public announcement logic is sound and complete, and obviously, PAL and epistemic logic are equally expressive. So going towards quantifying over announcements, we can shift our perspective from the effects of particular announcements to the question whether some information is attainable by any announcements. Or let's take more epistemic planning stance. We have some initial configuration and then the target configuration. Then we can ask a question, is there an announcement which takes us from the initial configuration to the target one? So in the paper, we consider what we call the big three, or like the big three of logics of quantified announcements. These are arbitrary public announcement logic, or APAL, group announcement logic, or GAL, and coalition announcement logic, or CAL. So for an example of APAL, let us go back to the Santa example, and then having this initial configuration, we can ask a question, is there an announcement such that Bobby learns that Santa does actually exist? And the question is yes, because this particular announcement, psi, deletes on this upper rightmost state where not P is true. And then now we can check that indeed in the updated model in state S, Bobby knows that Santa does exist. Another possible question to ask is it possible to make an announcement such that Bobby is certain about existence or non-existence of Santa in all possible worlds? Well, having this like a bit convoluted announcement, we can reach the corresponding target model, and then you, the listener or the reader, can actually verify that now, yes, in all states, if Santa exists, then Bobby knows that. And if Santa doesn't exist, then Bobby also knows this. So the logic with this type of operators is called arbitrary public announcement logic, which extends power with these constructs and their duals. For example, the diamond one says there is a truthful public announcement such that phi holds in the resulting model. So according to the semantics, for example, the box modality says that if for all formulas of epistemic logic, after these formulas being announced phi holds, then we know that the whole box thing holds. Also note that the scope of quantification. So we restrict the scope to the formulas of epistemic logic or equivalently formulas of public announcement logic so that the semantics are well defined. Now, a PAL doesn't actually tell us who makes an announcement or whether the announcement can be made by any of the agents modeled in the system. So to take a more like strategic perspective, we can consider only announcements made by agents or groups of agents in the system. So again, we consider the Santa example from a more strategic point of view. Can Alice inform everyone that Santa does exist? Can she inform only Bobby and leave Claire in ignorance? All these are valid questions. So again, we start with the initial model, and indeed, if Alice just says that I know that Santa exists, then the resulting model, updated model, will look like this. And indeed, both Claire and Bobby know that Santa does exist. And she can also inform only Bobby about that fact and leave Claire in ignorance, announcing this a bit, again, convoluted announcement, but nevertheless, reaching the target epistemic goal. So the logic of group announcements is called group announcement logic, and which includes this type of operators. And the diamond one says that agents from G have a joint simultaneous announcement such that phi holds in the resulting model. The caveat here is that we presuppose that agents actually make truthful announcements, or in other words, they know what they announce. So all announcements by agents are of this form. So these are, for each agent, the the announcement is preceded by the knowledge modality, and then the announcement by the whole group is the big conjunction of these announcements by particular agents. And so semantically wise, for example, the box one says that for all formulas of this type, and these are formulas of epistemic logic, phi holds after the corresponding formula being announced. So again, it's very similar to a POW, but the scope of quantification is a bit tighter. So while talking about GAU, we mentioned a bit of strategical setting. However, once we talk about strategies, it's usually we also take into account what other players do at the same time. And so usually like having a strategy means that someone can achieve something no matter what others do at the same time. The same can be done in the context of public announcement. So in the real strategic setting, we can ask, can Alice inform only Bobby that Santa exists if other children are allowed to spoil her announcements? And by spoil, we mean that they are they can announce anything they want at the same time. So in this particular example, of course, this is up to Bobby and Claire. So again, having the initial model, if Bobby and Claire remain silent, then of course Alice again can announce the formula she announced, like in the Gal example, and then only Bobby will know that Santa does exist. However, Bobby can spoil the strategy of A, and here we abstract away from particular announcements because they're a bit clumsy and they kind of not very intuitive. And another way to look at this is if agents are announced in equivalence classes. So, for example, agent A can announce all the states in the class which are connected by blue arrows. And then agent B announces all the states in the class which are connected uh, by these red arrows, and including this red P state. And so the resulting updated model will be the intersection of these equivalence classes, which are just two states. And we see that in this state, in this model, Claire also knows that Santa does exist, which basically means that Alice failed to reach her target epistemic goal because Bobby spoiled it. Also, Bobby can spoil it in more than one way. So this logic for reasoning about coalition announcements is called coalition announcement logic, which extends POW with these constructs. And for example, the Diamond one says there exists a joint announcement by agents from G such that no matter what other agents outside of G announce at the same time, phi holds. So announcements here again, like in GAU, are formulas that agents indeed know. But the crucial difference of cow from Apao and Gao is that in the previous two cases we have only one quantifier per construct, and now for each construct we have two quantifiers, and since cow was inspired by coalition logic, game logic, this is quite natural. So first we quantify over some choice or all possible choices by coalition, but at the same time we also quantify all the responses by the anti-coalition. So for example, The box case says that for all announcements by G, there is a counter announcement by the anti-coalition such that phi holds. And similarly for the diamond case. So let us let us summarize a little bit. So there is a PAL which allows quantification over all public announcements, GAL which quantifies over formulas that over announcements that can be made by groups of agents, and CAL which quantifies over announcements by a coalition, but also over responses by the anti-coalition. So we know that both APAL and GAL have infinitely complete axiomatization. It's an open question whether any finite axiomatization of the logic exists. Also, any complete axiomatization, finitary or infinitary, of CAL is an open problem. Complexity-wise, unfortunately, all of the logics are undecidable, and model checking for all of them is space complete. Expressivity-wise, APAL and GAL are comparable, and also CAL is not at least expressive as either APAL and GAL, meaning that APAL and GAL can express some properties of the models that are not expressible in CAL. The other direction is an open question. So what about the finite model property? That has also been an open question in the area of logics of quantified announcement for quite some time. So a logic has the finite model property if and only if every formula of the logic that is true in some model is also true in a finite model. And that's an interesting one reason why this property is interesting, that the lack of the finite model property says that the logics in consideration are so expressive that they actually have formulas that can only be satisfied on infinite models. Also, we know that for model logic, if they have finite axiomatization and the finite model property, then they're decidable. And however, this implication can be satisfied in many various ways. So we know that all of them are undecidable. However, the proof of undecidability doesn't explicitly construct an infinite grid. In particular, it constructs a finite approximations, and then the existence of the infinite grid is deduced. Whether the undecidability proof can be used for showing the lack of the finite properties is not clear. And moreover, our proof is much simpler and more elegant. So another way why exploring the existence of the finite model property is interesting, that if we could have shown that the logics actually do possess the finite model property, then we would have the non-existence of the finite axiomatization for free. But unfortunately, it's still the remaining open question. So in the paper, we prove the lack of the finite model property for these types of logics. And what we do, we present a formula of the logic, show that there is an infinite model where this formula is satisfied, then argue that the formula is not satisfied in any finite model. And then the proof can be found in the paper. So we considered three main logics of quantification over public announcements: PAL, which quantifies over all formulas of epistemic logic; GAL, which quantifies all the formulas that are known to agents; and CAL, where there is a double quantification over announcements by coalition and over the responses by the anti-coalition. And we showed that none of them actually have the finite model property. Thank you for checking out this video. If you have any questions, you can write to any of the authors via the email provided with the paper. Thank you.